All right, so 5.3 special products of binomials. We're on page 189 if you have not found that yet. Now with this, you'll see I'll talk about why these are special products, but as far as the formulas that come along with these, I won't fully expect you to memorize them. Where they'll be helpful is when we jump into our next module, which is factoring. Okay, but for right now, you're going to see we're going to end up multiplying it out. Now the way the book does it, it's going to be a little different than the way I do it, so I'm just going to go through examples and you'll see how we distribute and multiply this out as we did yesterday. Hey, so our essential question as we're working through this is, how can you find special products of binomials? And you'll see how this relates to what we've done in the past, and hopefully you can answer this question in context of what we've done already with products of binomials. All right, so this first one here, I'm going to model it for you, because this 2x plus 3 to the second power is probably the most missed problem for students when doing these types of problems. So I want to show the tile so you can see where every part comes from, and then after this we will just distribute it out. Okay, so we saw that we had 4x squareds, we had 12x's, and then we had 9 singles. Now the mistake that most students do on this is they distribute the power in and they get 2x squared, which is, or 4x squared, and then you distribute the power into here and we get plus 9. Okay, so going back and looking at our website there, and so what really needs to happen here is not just distribution of the squared term, but it needs to be rewritten so that you see 2x plus 3 times 2x plus 3. Because when we have something squared, that means itself times itself. So like x squared is x times x. 2 squared is 2 times 2. So 2x plus 3 squared is the same as 2x plus 3 times 2x plus 3. Now we do exactly what we did previous this week, was we're going to distribute. So I get 2x squared times, or 2x times 2x, which is 4x squared. 2x times 3 is 6x. 3 times 2x is 6x. And 3 times 3 is 9. Then we combine like terms. So we get 4x squared plus 12x plus 9. So notice we still had the 4x squared and the 9. We just now picked up our middle term of 12x. And then this problem here, what do you notice, or what do they both have in common as we look at the first one of 2x plus 3 squared, and then this one here, I have a 4x squared and a 9 on that one. Right? So those are one thing that's in common. And then if we look at our middle terms, it's 6x plus 6x. So on that same page, there's 2 more. I'm not going to do them with tiles. I'm just going to multiply this out as we've done. So now I have 2x minus 3 squared. So I'm going to write that as 2x minus 3 times 2x minus 3. Again, we're going to distribute. So 2x times 2x becomes a 4x squared. 2x times a negative 3 is now a negative 6x. Negative 3 times 2x is a negative 6x. And then negative 3 times negative 3 is a positive 9. And then as we combine our like terms, we get 4x squared minus 12x plus 9. Now as we look at this problem here, second one of 2x minus 3 squared, what do they have in common as we distributed out the terms? So as we look at this, there are a couple things that we have in common. I have a 4x squared and I have a 9 on this one. And on this one it's a negative 6x minus 6x. So our middle terms end up being exactly the same. On one of them they're both positive 6x, on the other one is negative 6x. So just giving you this terminology, these are what we call perfect square trinomials. Okay, because our ends, 4x squared and 9, are both perfect squares. So the 4x squared is 2x all raised to the second power, and 9 is 3 squared. So this is what they call a perfect square trinomial. You don't necessarily need to remember that after this point. You won't hear me mention it a whole lot, but it is something that you can be aware of and may be helpful as we move into the next module of factoring next week. Now, this next one here, sorry, laid out because these aren't the exact same terms. We have 2x minus 3 times 2x plus 3. So as we distribute this one, I get a 4x squared plus 6x minus 6x and then minus 9. Now this time when we combine like terms, what happens that did not happen on the previous two problems? Okay, so we did have a negative 9 on this one, but what else is going to be different about this one compared to the previous two that we did when I combine like terms? Yeah, our two middle terms are different, but only slightly different, right? What is different about them? Yeah, so the numbers are exactly the same, but now they are opposite signs. So as Jonathan said, those are actually going to cancel each other out now, bringing us to just a 4x squared minus 9. Now, of all the special products, this one's probably the most helpful. And what this one ends up being called is a difference of two squares, or difference of squares. Okay, and the reason is, again, we talked about already, 4x squared is a perfect square of 2x, and 9 is a perfect square of 3. So it's a difference, that's our subtraction sign, of two squares, the 4x squared and the 9. This one is going to be very helpful in the next module when we talk about factoring. So just remember this concept, what the beginning looked like, and then what our result is, okay, because we'll talk about that more in detail next week. Hey, so a couple others here I'll work through in multiplying. So we have x plus 4 squared, and I'm going to rewrite that out as x plus 4 times x plus 4. And then just as we did before, I'm going to distribute, so x times x is x squared. X times 4 is 4x. 4 times x is 4x, and 4 times 4 is 16. Okay, now the book shows you the notes of the whole formula where you plug it in. I'm not the biggest fan of that because that's something else for you to remember. So this is why I just distribute out, and then we combine our like terms, and we get x squared plus 8x plus 16. Now, yesterday we talked about a box method as well, or area model. Hey, we can do the same with these, so I'll do that for the second one here. So I will get 3x plus 2y down one side, and 3x plus 2y across the top. Draw our box, and again, where they multiply together, we fill those in. So 3x times 3x is 9x squared. 3x times 2y now throws some of you guys off. Just deal with each part individually. 3 times 2 is 6. And then x and y, are those like terms or like variables? No, x and y are not like variables. And so that means we can't combine those like we did when we multiplied 3x and 3x together. So we don't get like an xy squared or x squared y squared. All you get is just x, y. Now we get 2y times 3x, and that gives us 6xy again. And then 2y times 2y is 4y squared. Okay, remember when we multiply, we add our exponents. And so as I go to combine our like terms, I get 9x squared. Our 6xy's are like terms, so I get a 12xy plus 4y squared. And notice when I combined like terms, I did not change my exponents. When you add or subtract, all that changes is your coefficient, not your exponents. All right. So what you have here is a couple other problems. What I want you to do is work on these two on your own, and then I'll call on a couple of people to share out their work. Okay, so good. So distributing that out. So Jonathan did a good job of rewriting the x minus 5 so you can distribute out. The only small change that I would make on this, so you don't confuse yourself, is instead of writing x5, I'd write 5x so the terms are actually the same. But as long as that makes sense to you, that's okay with me. Personally, I just always write my coefficient in front of the x, kind of the mathematically proper, yeah. So, you still combine properly there. Okay, so box method here, which is fine. Again, I don't care what method you use, whether it's distribution or box. Now, as we look at this, is that correct? No. Okay, where's the mistake? Yeah, so when we multiply, we made a small mistake. We're going to just add those 6x's, so we just need to multiply that out, which gives us 36x squared. All right, so very good though. All right, now you've seen several of these types of problems, so again, I'm going to have you multiply these out, and then I'll call on 2 other people to share out on their results as well. All right, so as we look at this, we distributed, so that gave us x squared. Then we got 6x, and 36. Does everyone agree with that? Okay, Colton, why not?
Because one of the 6's has a negative in front of it.
Okay, good. So my first one, as I distribute that in, is going to give me a negative 6x, so this x times that 6 gives me that negative 6x. So let's be careful, make sure we pay attention to our signs. So now when we combine like terms, those drop out. And now from here, are we okay?
Yes.
Or are we correct? Is this 100%?
Whoa. No.
Why not, Reyes?
It's supposed to be negative.
What is?
35. 36, not bad.
Yeah, the 36 is supposed to be negative because we get a 6 times a negative 6, which gives us a negative 36. So just make sure when we are distributing out our terms, we pay attention to our signs as well. Hey, good. Hey, so do we agree or disagree with this one here?
Agree.
Agree, good. So we skipped kind of those middle terms, so if we were to multiply this out completely, show the steps, we would have x squared times x squared, which is going to be an x to the 4th. And then x squared times our negative 2y becomes a negative 2x squared y. And then a 2y times our x squared is a positive 2x squared y. And then 2y times 2y becomes our minus 4y squared. And then that's where our middle terms drop out, leaving us with that x to the 4th, 4y squared. Good. All right, so you have your quizzes. So get logged in that. I'll put this up, and then when we're done, we'll go over that. Okay, let's work through these problems here. All right, so first one, you guys did a good job of dealing with it because we have that other x squared in there. Doesn't matter what we have inside our parentheses, we are going to rewrite it. So I have 4 plus x squared times 4 plus x squared. Distribute, so 4 times 4 is 16. 4 times x squared is 4x squared. X squared times 4 is 4x squared. And then x squared times x squared is x to the 4th. Remember, we're multiplying, that's when we add exponents. Now I'm going to add, which means our exponents aren't going to change, we're just going to change our coefficients. Okay, so I have 16, my like terms are in the middle here, so I get 8x plus x to the 4th, which gives us an answer of D. Okay, next one. Negative x plus 3 times negative x plus 3. Distribute. Careful on this one. Negative and a negative. We're going to multiply that out. That gives us a positive x squared. And then a negative x times 3 is a negative 3x. 3 times negative x is negative 3x. And then 3 times 3 is 9. Add our like terms there in the middle. And you get x squared minus 6x plus 9. Okay, number 3. You get 4x minus 3y times 4x minus 3y. Now, just because we have an x and a y, the process does not change. You distribute. So 4x times 4x is 16x to the 4th. 4x times a negative 3y. 4 times negative 3 is a negative 12. And then x times y are not like variables, so we just get xy. In the middle we get the same thing. And then negative 3y times a negative 3y is a positive 9y squared. Combine our like terms in the middle, and we get a negative 24xy plus 9y squared, giving us an answer of B. Okay. So careful, some of you chose D because when you added, you did 24x squared and y squared. Remember, when we add, we do not change our exponents. We only change the coefficient. Okay, number 4. 3 minus x squared. 3 minus x squared. Distribute, and you get 9 minus 3x squared minus 3x squared plus x to the 4th. Combine the like terms and you get 9 minus 6x squared plus x to the 4th. And that gives us A. And last one. So I set up as separate because they're not like binomials. So 7 times 7 is 49. 7 times negative x is a negative 7x. X times 7 is 7x. And then x times negative x is a negative x squared. Make sure we're careful with those negatives as we are multiplying. As we saw in the previous example I had done for you during the notes portion. Combine our like terms in the middle, and then this time our like terms cancel each other out, and we're left with 49 minus x squared, which our answer is B there. Alright, so our question to end with is, how can you find special products of binomials? Okay, so one we just did, you can use distribution method just like we did yesterday. What's the other way we can find our products? Okay, so we can do what we call the area or the box method, right? Either of those. So really, even though they're special products, our process from yesterday did not change. Okay, and there's your homework assignment. That will be due Friday.